Hello. We're going to be doing merge sorted array today. So we're given two integer arrays, and they're both sorted in non-decreasing order. We're also given m and m, which represent the number of elements in each array. And the goal is to merge these arrays into a single array sorted in non-decreasing order. We're given a nice constraint or guarantee that nums of 1 has a length of m and m. And they also want us to sort this array inside of that nums1 array. Cool. So let's look at an example. We have nums1 and nums2, and we're given the number that represents the amount of numbers in that array. So you can see that 3 plus 3 is 6, and nums of 1 has a length of 6. And the output is as following, which would be 1, 2. It doesn't really matter which 2 since they're equal. I'll just do this one, 2 again, 3, 5, and then 6. And that's how we get our output. All right, let's start diving into an example. When I first look at this problem, I think it's pretty easy to answer this if we had a separate array. We would just have 2 pointers, and we would just say which one's least, added to the array, move the pointer, which one's least, added to the array, and so on and so on. But in this example, they want us to do this in place. Now, I think the same thought process works here. When we're dealing with something in place, we typically want to use pointers. And so we'll have these 2 pointers, and we'll say if one of these, or we'll say comparing these two, which one's least, leave it in the merging array, which is going to be the first array. In this case, 1 is greater, or 1 is least. In this case, 1 is less. So we're going to move the pointer over, leave it alone. In this case, we'll just say this 2 is less. We'll move it over and leave it alone. 2 is now less. So we're going to want to store this 3 somewhere and put this 2 in here. And we're going to want to move both pointers over. Now, 0 is less than 5, but we're also at the end of this first array's limit, which was 3. And we also have something in our store or in our remainder. And so normally we would add our 5 into this place, but because we have something out here, we're going to say which one's least, 3. So we'll actually add 3 here. And then we'll move the pointer. Again, 0 is less than 5, but we're also out of bounds. So we can just start adding this other nums into the array. So if you thought to yourself, that felt a little messy, or I feel like it could have been better, then you're actually right. When you go through your thought process and you think it might be a little complicated, there's typically a better solution. So keeping the idea of 2 pointers, what's another approach that we can take to this? We know that the first input array is going to be the size of m and m, which is 6. So those are our constants. And we also have these 3 kind of placeholders for us to add our numbers. So to me, it kind of makes sense to start our check near the ends, because once we input a number, it's going to fill in the placeholders rather than starting from an area where the numbers are already filled in. So we're going to need a reference to this pointer, but we're also going to need a reference to this pointer, because these 2 are actually the ones that we want to check. And this one is just telling us where to insert our number. And so we'll have 6 and 3. Which one is greater? In this case, 6 is. So we'll actually put our 6 here, move the pointer, which is greater, 3 or 5. And also move this. 5 is greater, so we'll add that here. Move our pointer, which is greater, 3 is greater, so we're actually going to remove this, add our 3 here, move our pointer. There's actually still a 3 here. But it doesn't matter because we already went through this element. So which is greater? In this case, we'll just say this 2 is greater, even though they're the same. So we're at the 2. We are at the end of this array, but we can still keep going on this side. And in this case, there's nothing to reference, so we can actually just end our loop there because we know that this array was originally in sorted order. And if there are no other elements in the other array to check, then we know that this is already sorted. So that felt a lot simpler, and I think that's the approach we're going to go through. All right, so let's run through our code. Like we said, we're going to have 3 pointers. Let's say I is going to be the pointer for the nums1's numbers, right? And that's given to us through m, right? M is the length of the amount of numbers that are in nums1. So we're going to do the -1 to get the right indexing. J is going to be nums2, which is going to be n-1. And we'll call k the pointer that's at the end of the nums1 array. Remember where all those placeholders are. And that's given to us by saying m plus n, right, -1. So the first array to go is going to be nums2 array, right? Because we're merging in to the nums1 array. We know that nums2 will actually always be the first one to go out because the last few elements in the nums1 array are placeholders. So we're going to say while the j pointer is greater than or equal to 0, right? Because we're going backwards. We're going to do our calculations. And so we'll have the 1 number, or nums1's number. I'll call that 1. That will be nums of 1 of I. And then we'll also have nums of 2. We'll call that 2 of j. And we're going to want to do our checks. So if 1 is greater than, if 1 is greater than 2, I know that seems off, the naming is bad, but if 1 is greater than 2, then we're actually going to insert the nums1 array at k. We're going to insert the greater number, in this case 1. And then we're going to want to decrement the index in which we were using, so that's I. We're also going to want to decrement k, right? Else if the other one would be if 2, I'll just say 1 again. 1 is less than or equal to 2. In this case, if 2 is greater, then we're going to say nums1 of k needs to equal 2. And we'll decrement j, because that's the index we were using, and we'll also decrement k, right? And yeah, we can see that we're just, I think these are the only 2 conditions that could happen, right? Because we take care of both less than, equal, and greater than. So we can see some similarities. We can take k out of the equation and just have that at the end of our loop. And yeah, this is essentially it. We can run it, see if it works. So we're getting a time limit exceeded when nums of 1 is 0, m is 0, and so on. So that's likely happening because when m is 0, 0 minus 1 is -1, and we're not doing any checks for that. So we have the j is taken care of because that's what we're using to loop, but we don't want to have undefined in our checks, right? So we're going to want to make sure when we're checking for I, that I is greater than or equal to 0 as well. So if that is the case, and that 1 is greater than 2, we're gonna handle this. Else, since this is our only case, we don't need to do that. So that's accepted. Let's see if the submission works. And there we go. So yeah, a little tricky there, but just know that if we did else if what we had before, I don't think it would work. we aren't accounting for this I check. So let me check. Yeah, so yeah, because this is still false. So I guess we could say if I is less than 0, 4. I think that would work. Yeah. But you know, we don't want that. We don't need to keep track of it. It's only 2 conditions, so you want to do that, Alice. Thank you.